All right, so I want to do a quick example of mergeSort for you before you implement it, just to show you how it works. And this is a small example because not a lot of board space, and you'll see why I need board space in a second. So mergeSort returns a sorted array, okay? So mergeSort returns the sorted version of the array. So we have a function called mergeSort, and we'll have another function called merge that's called from mergeSort, and that's the second part of this algorithm, okay? In this case, maybe it returns an integer array, okay? Because we have integer values. Maybe these integer values, I don't know, represent shades or something, right? I'm gonna do this. I'm gonna really jumble. Well, maybe this isn't the smartest thing to do, but I'll go 10, 13, 12 or something like that, okay? All right, so we got mergeSort and we pass in this array as our parameter, okay? And we could call it R2sort. Not the best name, but whatever, okay? It's an integer array. And this is the integer array we're going to sort and return, okay? First thing we do is we split this up into two parts. You can do this with, there's a way to make subarrays in the java.utils.arrays. And if you want to use that, go right ahead and use that. It's actually not hard to go through here. You take the length, you divide it by 2, right? And then you grab everything from 0 to length over 2 and you put it in one array, okay, in a for loop, right? And then you grab everything from length over 2 to length and you put it in another array. So you could have subarray 1 will, after this process, be 22 and 10, okay, and then subarray 2 after this process will be 13 and 12. Now, remember that it really doesn't matter if there's an odd number and one has 3 and one has 2. It has no meaning to it. We're going to have to actually put something up here, as you'll see in a second, that returns when we get to 1. Remember, we're trying to get to arrays of size 1. So if we get to an array of size 1, we know we have to return, okay? So notice how we called mergeSort on this array and it split it in half. And we're trying to get to arrays of size 1. So why don't we just call mergeSort again on it, right? Because we called it once, it splits it in half. So if we just call mergeSort on these two, it will split those two in half and we'll get to arrays of size 1. So that's where it becomes recursive, right? We have something that splits arrays in half, so why not just recursively call it? And remember, that's your intuition with recursion. We'll talk about this more in trees. It'll be more fun with trees. But here, it actually makes sense, right? I'm trying to get these things to array sizes of 1 so then I can put them back together. If I split it in half, I'm still trying to get it to array sizes of 1, but I've done a step and I've gotten 2 problems that look exactly like my original problem. I still need to split these things in half. So when you have a self-similar problem like that, literally you take a step towards the solution and you're confronted with the same but simpler version of the same problem, you know that, hey, maybe this has some sort of recursive solution. Like climbing the stairs. We've done that example before, right? You take a step and you're confronted with stairs again. It's the same exact problem, except it's slightly smaller, right? Same thing here. All right, so what do? Well, we're going to say, okay, subarray 1 equals, and we'll say mergeSort subarray 1. Okay, and what does that do? Well, this stops right here because it can't move on until that's been evaluated. And how does that get evaluated? Well, we're back in mergeSort. So we've invoked mergeSort from within mergeSort, and now we're calling mergeSort with this kind of array, 22 and 10. So that's when we talk about inception. We're within the dream, where now we've jumped. Or Scary Terry on Rick and Morty. Not a bad episode. And so now I think it's the second episode, right? It's good. It's good. Actually, it might be inappropriate. It's all right. Whatever. Okay. Merge sort. So now we've got this, right? And what it's going to do is it's going to split these up, okay, into two different arrays. So subarray 1, and I'm just going to go SA1, will equal 22. And subarray 2, I can put it in a little box if you want, will equal 10. Okay? So we've got one value. And then what we're going to do is we're going to hit merge sort again. Now, there's a problem here, and that is, you know, if we try to split apart something that's 1, it's not going to work. So we have to have something called a base case that stops this recursion when we get to the place we want to get to, which is these things equal 1, okay, or of a size 1. And so the way we do that is up here we say if the if the array to sort is length 1, return. Okay? And so that's up here too, merge sort. And that's the base case. I'm just going to say this arrow means the base case if it's of length 1, right? But this one isn't of length 1, it's of length 2. So we break it down into 1, and then we call merge sort on SA1, right? So we say SA1 equals merge sort SA1, right? And SA2 equals merge sort SA2, okay? And now these are 1, right? Because we're calling merge sort on 22. So here, for example, SA1 is 22, and we call merge sort on 22, and merge sort returns. Because this is of 1 and it hits the base case. So now we're on the next one. SA2 equals merge sort of SA2, so we have to evaluate this, and merge sort returns. So we now know that SA1 and SA2, okay, are sorted. Now, what do you mean they're sorted? Well, if it's an array of size 1, isn't it sorted? So they're literally sorted, right? Their array of size 1 is literally sorted. And now we need to combine two things of array of size 1, and that has to be sorted. So every time we return from merge sort, whatever we return has to be sorted. So after this, and I'll do it in the main function over here, and then we'll assume it's in that function. We've got to do this thing where we merge subarray 1 and subarray 2, okay? And that's the step we're on here. We've gone into the recursion. This is waiting on this. This is waiting on this, right? So that we're two functions in, right? And now this one needs hitting the merge step. Okay, so we're calling merge with 10, with subarray 1, which is 22, and subarray 2, which is 10. And we've got to merge them in a cool way. So we have this going on, and we have an index pointer here, and an index here, and an index here, okay? And we check which one of these is smaller, and 10 is smaller, so we put 10 there. We iterate this index up, but since it's bigger than the length of this array, we're done here. And so we break out of whatever loop we have, and we'll look at that loop in a second. And we end up putting 22 here, okay? And then, so now this is sorted, right? 10 and 22, okay? And so then we return, and since we return here, subarray 1 here is now sorted, right? Subarray 1 is now sorted, and it's 10 and 22. Similarly, we'll do the same thing with subarray 2, and it'll come back sorted with 12 and 13. And then we're going to merge these two, because we hit that merge step again, and then we will get 10, 12, 13, and 22. Let's talk about the merge step now. How does the merge step actually work? And you can see that pseudocode in there. I just kind of want to explain it, though. So if you're merging two things, okay, so every time we return from mergeSort, it's sorted, right? 10. And so we've sorted subarray 1 and subarray 2, and now we're going to merge these things. So we pass it into our function merge, okay? And all merge does is it first creates an array that can hold all of this stuff, okay? And then what it does is it says, well, I need to compare, so I'm going to put an index over here and an index over here, and I have an index over here to keep track of how many numbers I've put in. And then I'll say something like while, and I'll call this in1 and in2, right? And I'll call this the final end, because that's the one we're going to return, okay? And we can say something like while in1, right, is less than the length of this array, so subarray 1 dot length, and in2 is less than this one. All right. What we're going to do is we're going to compare them. So we say if subarray 1 in 1 is less than subarray 2 in 2. Okay, and in this case, is it? Yep, it is. And so then we're going to add it to fn. So we'll go oh, that's fn. I'm going to call this to return. To ret, okay? We're going to say to ret fn equals and subarray 1. Okay? In 1. All right? And then we have to update this. So find fn equals fn plus 1, because we just wrote 10 here, right? That got written to 10, and so now fn comes up here. And since that 10 got written to the final array over there, we also need to do the same to in1 equals in1 plus 1, right? So now in1 is over here. All right? Cool. In the other case, which is what it's going to hit here, right, we're going to have an else, and it'll have all of this with in2, right? So to ret find equals sa2 in2, right? Because now this one's the smaller one. And so 12 gets written here. We've got to update this one. And we've got to update this one because we hit the else. And now we're doing this again. And we'll hit the else again, right? 13 and 22. So 13 comes here. Okay. And now this falls off the end of this array, right? And this is pointing to, what did I do wrong here? 10, 12, 13 comes there. Oh, right. This is pointing here. I didn't do anything wrong. Okay, so now what happens is we kick out of this while loop because in2 is now greater than its length, right? So we kick out of this while loop, and then all we want to do is we want to take all the remaining values and just copy them in, right? Because once we've gone off the edge of one array, we know the other array is in order because it was always returned from mergeSort in order, right? because it already got merged. This got merged right off the bat, right? So it's merged, and it's correctly merged, so we know it's correctly merged. So after we kick out of this while loop, we find either one that hasn't hit its length yet, because one of them hasn't hit its length yet, right? When we break out of this. And so whichever one hasn't hit its length yet, so in this case, it'll be in1 is still less than its length. We'll just copy all the rest of the numbers in, iterate up in1, iterate up fin, and in this case, it's only that. So we have this thing totally sorted, okay? And that's what will be returned from mergeSort. So we're going to return this from merge, and then mergeSort will return this back up, and we'll get a sorted array. All right. I do get that this is long, and so the assignment version of this will have each of these steps commented step by step by step, and then you will do it. But you know how to do each of these steps. You might not know how to put them all together exactly right, and there's some hiccups along the way, but it's not going to be too bad. Just make sure you keep all of this in mind. And if you have a little trouble, you can always watch that earlier video or that mergeSort in 3 minutes video. It even has pseudocode at the end, so you're not ever completely lost. Okay, but this will be useful for you when we start looking at recursion. See you next video. I should do a video within a video. Okay, forget it. Wait, I could do it with my phone. I'd be like, what? It's just stupid. I'm sorry. See you next video.